10th class. Problem. Three registers, 10 ohms, comma, 20 ohms, comma, 30 ohms are connected in a series B parallel. Find the resultant resistance. Resistance in the circuit. From the given circuit, here solution. This is physics electric current lesson. From the given circuit, R1 is equals to 10 ohms, R2 is equals to 20 ohms, comma, R3 is equals to 30 ohms. So resultant resistance in series connection, R is equals to R1 plus R2 plus R3, that is equals to 10 plus 20 ohms plus 30 ohms, that is equals to 60. 60 ohms. And next B resultant resistance in parallel connection, in parallel connection, that is 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3, that is equals to 1 by 10 plus 1 by 20 plus 1 by 30. The LCM of this 10 comma 20 comma 30, it is LCM is 10 ones are 10 twos are 10 threes, 3 to the 6 into 10, 60. LCM is 60, so we write here 60 here, 10 6 are 6 here plus 23 is plus 32 is that is equals to 6 plus 3 plus 2, 11 by 60. It is 1 by r. So r will be equal to 60 by 11. That is on dividing, it is converted into decimal 5.5. 60 divided by 11, 5.5 ohms. Okay. So next, another problem. Observe the given circuit and calculate the resultant resistance. Here circuit is given. So this is the circuit given. This is 4 ohms. This is 12 ohms. This is nothing but 7 ohms. 3 ohms are given. So here from the given circuit we take R1 is equals to 4 ohms, R2 is equal to 12 ohms. These two resistances are connected in series, these two resistances are connected in parallel connection, parallel, parallel connection. 4 ohms and 12 ohms are connected in parallel. So their resultant resistance, that is we take from the formula 1 by 1 by R is equal to 1 by R1 plus 1 by R2. R implies that we can take R is equals to, that is R1 into R2 divided by R1 plus R2, and R is equal to, this R1 means 4 into 12 by 4 plus 12, that is 4 into 12 by, this is 16. Now 4 fours, 4 ones are 4 ones are 4 threes are. That is equals to 3 ohms. Effective resistance or resultant resistance when connected in parallel is given by 3 ohms. And this R1 comma R2, both these are connected. Both these are connected to R3. That is R3 is given by 7 ohms with R3 in this is in series, it is connected in series. R1 R2, these two resistances connected to R3 in series. So resultant resistance or effective resistance is given by resultant resistance. Effective resistance. It is, we take R is equals to this is nothing but the parallel connection. Resultant resistance is 3. This 3 ohms plus this is in series connected with 7 ohms. So 3 ohms plus 7 ohms is 10 ohms. This is the total resultant resistance in the circuit. Next, one more problem. So this question, resistance 2 ohms, it is, this is 2 ohms, this is 2 ohms, and now this is the point A resistance. A, B, C are connected as shown in figure. This is A, this is B, this is C, connected. Here A, B, C are connected. Are connected as shown in figure. Hmm, each of the each of them dissipates energy to a maximum of 18 watts. Each of them dissipates dissipates a maximum dissipates energy to a maximum of 18 watts. 18 watts. Find the maximum current that can flow through the three resistors. Find the maximum current that can flow that can flow through the three registers. Three registers. So here the resultant resistance in the circuit is given by resultant resistance in the circuit. It is equals to, this is connected with this in series. A is connected in B and C is, it is series, and B and C are connected in parallel. So A we write 2 ohms plus B and C effective resistance or resultant is 1 by 2 plus 1 by 2, that is B and C. And on taking this 2 plus 1 by 2 plus 1 by 2, it is nothing but 2 plus 1 by 2 plus 1 by 2 is 1, that is equal to 3 ohms. And now we have power is equals to I square R formula. So we want to find current I, that is I square is equals to power P by R, implies that I is equal to under root of P by R. Under root of P means power is nothing but it is given that 18 watts by resistance is given that is effective resistance, total resultant resistance is 3 ohms, that is equal to 3 ones 3 6, that is under root of 6, and watts by this is power. Current is measured in, this is amperes we take, that is nothing but root 6 amperes current, that is the current flown in the circuit. One more problem. Okay. One more question. How do the registers do the registers 6 watts, comma 10 watts to be connected in a circuit to get a minimum resistance? Find the resultant resistance of the circuit. Find the resultant resistance of the circuit. So resistor 6 ohms. This is we should take not given. This should be ohms we have to take. Why? Because of this is in the problem given wrong. This is 6 ohms resistance and 10 ohms resistance, and this should be connected parallel connection in a circuit to get minimum resistance. Minimum resistance రావాలంటే reciprocal లో ఉండాలి. So answer will be answer. First question. Answer is resistors 6 ohms, resistors 6 ohms, comma 10 ohms should be connected. Should be connected in parallel connection. In parallel connection. In a circuit. In a circuit. To get minimum resistance. To get minimum resistance. Minimum resistance. So this is over, and find the resultant resistance of the circuit. Resultant resistance means whenever it is connected in parallel connection, the resultant resistance is given by R is equal to 1 by R1 plus 1 by R2. Sorry, 1 by R is equals to 1 by R1 plus 1 by R2. And R is equals to, we can write R1 into R2 by R1 plus R2. That is equal to R1 means 6 ohms into R2 means 10 ohms by 6 plus 10. That is 60 by and 16. And on dividing 60 with 16, you will get 3.75 ohms. That is the resultant resistance. Next, one more thing. Yes. More question. So it is one question. 3 equal resistances. 3 equal resistances are connected in series, then in parallel, what will be the a ratio of their a resultant resistance. So equal resistances. Suppose the resistance of equal resistors is, we take equal resistances, that is equal resistances is given by R comma R comma R. This is so first they are connected in series. In series connection, they are connected in series. It is R plus R plus R is equal to 3R. This is, we take R dash equal to 3R. And now they are connected in parallel, then connected in parallel connection. So parallel connected, that is R double dash is equals to R, we take 1 by R double dash, we take it is equal to 1 by R plus 1 by R plus 1 by R. R 1 by R double dash is equals to, this will be 3 by R, we take here, this is LCM is R 1 plus 1 plus 1, it is equal to 3 by R. So R double dash is equals to, this is nothing but R by 3, and the ratio of both these, it is the ratio of resultant resistances, ratio of series connection and parallel connection, ratio of resultant resistances, it is implies that R dash is to R double dash, that is equal to R dash is 3R ratio, this is R double dash is R by 3. So this R1 R, this is R cancel, that is equal to 3 is to 1 by 3. On taking LCM and multiply the ratio 3 by 3 with this, 3 is to 1 by 3, that is equal to 3 3 is a 9 is to 3 into 1 by 3 means 1. The answer is 9 is to 1.